Hello, my name is Eddie Tudorano. I'm a professor of information science at University of Arkansas at Little Rock, and I'm serving as a track co-producer alongside Samantha Maxim and Prashant Sutakal for Virtual Track G, Global Issues in Data Analytics and Management. It's my pleasure to introduce the next session, How to Leverage Insights Engine for Personalized and Actionable Recommendations in Financial Domain. So in this session, you'll hear about the Insights Engine. It's just a way to provide a high level of customizations to consumers of financial service industry. In the financial industry, they don't have kind of the same personalized experience they can get in other industries such as entertainment or e-commerce and so on. Before I hand things over to our speaker, a few housekeeping items. First of all, this session is being recorded, and the recording will be uploaded to the CDOIQ YouTube channel about 3 months from the symposium. Any presentations that you see today will be included in the symposium proceedings. And the final one, we have a question and answer sections at the end. And if you have questions, please submit them via the Whova app, and I will read them at the end. With that, I'll turn things over to the session speaker, Dr. Pramod Singh. He's the Chief Analytics Officer and Vice President of Data Sciences and Analytics at InvestNet Yadvid. Pramod, over to you.
Thank you so much, Eddie. Thanks for the warm welcome. Let me start sharing my screen. So yeah, so as Eddie said, I think I'm going to talk about a bit around Insights Engine. How do we develop that, right? This is my second time here at CDOIQ. The last time I came in, I talked about how to develop and deploy a big data science solution. So we went into the detail about talking about that. This year, I'm going to take the more of a data management approach to it and see how data sciences get deployed, but how data management and other aspects play such a big role into a healthy deployment of that. And along the way, I'll talk through my journey right now of how do we develop our organization and how the value creation happens, right? So moving to the little bit about myself, as Eddie said, I run data sciences and analytics for InvestNet Yodlee. I have been in the space for 27 years, starting out with Walmart's information system, had a stint at Hewlett Packard, where I led data sciences. Just realized that Eddie is also from University of Arkansas. I have a PhD from there. Currently live in Raleigh, North Carolina, right? And about us as a company, we are a global leader in the data aggregation and analytics space, working with a lot of financial institutions on dealing with a lot of financial data, and I'll talk about that, in a little bit. So if I go in today's session's objectives, right? This is a session on the data management track. So I will walk us through the data life cycle in a lot more detail, right? Starting with the data management part of it, I'll talk about the evolution and the maturity. Then we'll go to the data transformation, where the foundation of the value addition happens, right? And in our domain, how do we take transaction data and how do we enrich that? We'll talk about that. And the last part, obviously, is we put it together to generate insights, right? I will end with talking about the data value. How do you create the value? I'll talk about the framework, right? But very important that as we go through the presentation and as you guys evolve through different here in the different industry segments, keep the end objectives in mind, right? Let's not do this in vacuum, right? Or in a theoretical framework, right? Because each industry, each company has different objectives to go do that. Having your end objectives in mind is very critical to making sure a success of a program where you are trying to go deploy these solutions, right? Into your organization. So let's start with the data management part of it, right? Let me set the stage up a little bit here in terms of what we do. Our lowest grain of data is something called a transaction data, right? That is a data when you go swipe a credit card, at Starbucks, or you write a check, to your landlord, or you're using your debit card, that's a financial transaction data, right? And all of us here probably have a credit or a debit card. We have seen a financial transaction data, which will probably have a date stamp. It will have some sort of description. It will have some sort of value. And that is essentially is a transaction data, right? We, as an aggregator, we get more than 100 million of those a day. And that I'll talk about our journey of how do we go infer different attributes from there, and how do we go enrich that class of data. We work with more than 700, active financial institutions, across the country, across the world, have 30 million plus active users who are transacting, right? And you can imagine, with that kind of a volume, with and having the right data sciences behind it, you can generate lot of very actionable insights, right? Which will be a real representation of what's happening in the US economy. This class of work over the multiple years has resulted into us creating, a historical 100 billion plus transactions. We have evolved into a big data repository and a data warehouse. Now we are more than 3 petabytes of data, actionable data that we are using, right? In different, from raw to enriched form, right? So this is a little bit about the size of the data that we work with. It's important that when we look at our data, that we look at the entire data life cycle, right? In terms of data management, this is something I think we have all seen, we are all familiar with, but it's important to kind of look at the data life cycle, right? Started with the data gathering part of it, having efficient ways to go gather your data. In our case, data comes in multiple different ways, everything from getting batch feeds to getting data from third party to from screen scraping, then data cleaning and sorting, right? Especially a lot of data that we get could be potentially unstructured, right? So making sure that there are enough processes in place to go do that. Data storage, we are evolving to be a cloud native organization, right? And use data for easy access. Data enrichment is there. This is where a lot of magic starts to happen, right? In terms of taking the class of data I talked about as the raw transaction data, and how do we go enrich that part of it. Data governance typically have been, I've seen that in a lot of my peers' organization, typically has been an afterthought, right? I do say that it's important that you weave in the data governance principle, as part of your processes as you start evolving as an organization, right? And the last part is, how does all this, help drive data-driven decision making, right? So what is important here is that at each step of this, life cycle, you see here, the data is getting transformed and value addition is happening, right? And that is very important, right? That as we go through managing our data, and look at the different aspects and the different parts of the life stages, we are adding value to the adding value to the data, adding value to the processes, right? And very important that we kind of keep these sort of operating principles in mind, as we evolve as a data enabled organization, right? And all of this I think we have done over my journey at this company, and I'll talk about that in detail as we go forward. Let me give you a little bit about our data evolution, right? As I talked about it, over the last 7 to 8 years, and lot of different classes of data that we deal with. Started out with processing in classical RD BMS systems, right? But as the volume of data and the compute starts to become important, we sort of at that point of time, what was called the big data environment moved to the Hadoop class of environment. And again, the driver for there was that we needed plain data storage and high volume of data storage that help us drive to that part. And as our sort of analytics and data sciences start to evolve, the data started to get more complex, right? And we had a lot of limitations in terms of in-house clusters that we have. We were getting started with started to deploy data science models, right? We needed a computation at scale, right? And that's where I think we went to cloud. One of the cloud providers that we worked with created our data lake there, and which became sort of a foundational element of how we evolved over time from there, right? And over time, then when we started to the volume of data became very big, the variety of data became very big. We had big, massive machine learning models in production that needed to be monitored carefully. We had the feedback loop coming in. A lot of processes got we evolved into an automated machine learning process, right? And internally called it as analytics as a service part of it. And then data lake got enhanced, making sure that we have the lineages, right? And automated data processing became big for us, right? And as the journey evolved, right, and a lot of our customers started to demand, real-time delivery of data, right? We went from what we were initially a stateless to a more of a stateful, microservices became very important. And then, I think we started to put, a massive processes around, our data governance part of it. But the driver here was obviously one of the big drivers was, ability to go provide a lot of this data into near real time, and the compute and the started to get a lot more complex, right? And then I think over the last year or so, I think we have now built out a completely unified platform, right? With the streaming as a backbone, right? And built a cloud native scalable architecture, right? And again, this is a journey where we went through multiple missteps along the way. We learned from it, evolved through that, right? But as I said, now through the processes, we are supporting 3+ petabytes of data, massive processing that happens every day, active customers that I'll talk about later, right? But has been our sort of a data journey over the last few years. I'm dramatically simplifying in terms of the lower level details, but I thought this would be important to kind of show that how we have evolved. It's not a linear process per se that we took steps. There were technology decisions that we took did not work, made changes, right? But we've evolved to a stage where we feel very comfortable, right? And serving our customers. As we sort of go through the evolution here, right? I do want to talk about our data philosophy, right? And again, there's nothing right or wrong about it. But what I do want to talk about that how as we evolved as a big organization, part of our business, which is now analytics learn, how did we use, what is our basic data philosophy here, right? I think one of the operating principles we work with is to separate compute and storage, right? It's very important to kind of segregate the concerns, and this provides a lot of efficiencies, and more importantly, I think the segregation of concerns is something that that is important, that the processes are not tied together. The second operating principle is single version of truth, right? And this is something I have grown with, in my career, right? Very early in my career, I had worked at, Walmart's information system and the CIO there, Randy Mott has always talked about that, right? So when you are querying your data, make sure I think you're getting the same output back, right? I mean, since then, over the last 10, 20 years, we have evolved. I mean, the data does not have to be physically all at one place, but very important that, that you are reporting the same output back, for the same class of data, right? Third one is being cloud native and vendor agnostic. This is again a learning over the last 5 to 6 years that you build for cloud first. You assume anything and everything can potentially fail, right? But you build around that, and that's where microservices, containers, and DevOps, are kind of come into the play, right? The next part is strong contracts and open standards, right? Anytime you are storing data or moving data, ensure contracts between the systems, right? And it's very important that that we do that, especially when there are multiple processes involved. In the workflow that we have, it's not the classical, ETL per se. There's a lot of data science components involved, right? So strong contracts and open standards are important, and self-serve data infrastructure, right? To power our data science, and to democratize, data. Very important that we have a self-serve infrastructure. And all this is sort of governed through our data governance process for security, for quality, and all other aspects of data, right? And this does help provide data-driven products, platform, and decision making, right? Again, this is our philosophy in the industry segment that we are in. Does not have to be exactly for all industry segments, all use cases, right? But this is something that we go back to, when in doubt, right? That the philosophy that we have evolved, over time. And this again, you can see our evolution, that how we went from sort of in-house to a cloud-based compute for most of our data science classes of processing, right? Now, moving forward, if I look at our ecosystem of data, and I wanted to kind of take some time to talk about that, and this may be a journey from what I call the information value chain in some sense, So we have a lot of data that comes in, right? I mean, as I said, we have third-party data, we have data we generate through our processes. A lot of that goes to our OLTP, and then as I'm talking about horizontally, our value chain, information value chain. There are 5 steps involved, I think, in terms of curating data, right? So we ingest data. We prepare and curate data where data quality comes into play. For our data, a lot of our models are probabilistic in nature. So we have to go build ground truth for our data scientists to go work with. So we have to label our data through our human experts, right? And this is where the man-machine kind of a congruence comes into the play. A lot of data that we work with is also the reference data, right? That is coming from external sources. We use analytics and data sciences to go build, multiple what we call elemental classes of, enrichment, and I'll talk about them in a little bit. We go from, ingestion to preparation to analytics, and it's important that we have an ability to go visualize our data, right? So the visualization happens either through dashboards or internal web tools, and then we have to go provide access to the data. And the delivery mechanism happens, either analytics as a service, which is an API-based delivery mechanisms, or we are sending data, through flat files, or there are applications built on top of it, or with the UI part of it. But what is important is that as we move up the food chain in terms of the information value creation, here are some examples of what we call the elemental enrichments. So you're using data science for elemental enrichments, right? I'll talk a little bit about transaction data enrichment. I had a detailed talk last year there, that how do we take transaction data, enrich that. We have an ability to go in for income, or geolocations. So these by themselves, are elemental level enrichments, which are then taken then evolve into certain products, right? And some of the names are here, like peer benchmarking or credit engines, right? And then those together fuel our different business units, right? So this is sort of an information value chain, right? That you take the data, you go through the 5 steps of it, you do the elemental enrichment, you build things on top of that, and those are the ones which are fueling your different business units. This is all happening because we have a solid technical framework, right? Or in some sense, what we call the IT value chain, right? And the IT value chain is very, very important, because none of this will happen unless we have the right IT value chain, right? This is, if I look at it, it's supported by an infrastructure layer, which has networking, computing, and storage. But more importantly, as I said, all of this does not happen in vacuum, right? It has multiple components. So we have built out a platform, right? Which has multiple components in it. I'm calling out few of them here. Hadoop is sort of used as our, what we'll call the data refinery, just to go host data. On Amazon S3, we have created our data lake. We use real-time PostgreSQL, for querying, we use Redshift as our warehouse. We use Athena for querying, on S3, which are on the flat files. We have certain applications which are where we use MySQL as web applications for efficiency of compute, right? We use a lot of caching, because, as I said, these models have to run maybe 100 million times a day on different transactions. So, and the things which we have seen already, we use a bunch of caching there, right? And we use Glue for where all metadata is kept, right? So again, just a little bit of a glimpse about the technology framework. I'm not talking through all the lower level of details there, and then the delivery happens, through depending on the use case that we have a lot of users that that are using the batch-based solutions, and we use a lot of Spark over there. Then we have interactive solutions, right? Where customers are directly interacting with us, right? We use Hive to go query Impala, query Hadoop, and we use Impala to query Kudo. And then, as I said earlier, right, there are streaming-based solutions. Kafka is extensively used that, right? And then all this is sort of managed through a very strong resource management system that the team has created, right? And we use Airflow for automating our pipelines, right? And Kubernetes for orchestration, right? So this, in some sense, is our ecosystem, right? So if you look left to right on the top, it's the information value chain. If you look from bottom to up, it's the IT value chain. The point I'm trying to make here is, this does not happen in vacuum, right? So you have to put the right infrastructure, the right processes, the right tools, the right technologies, the right resources in place for this to happen. And again, before I move to the next section, right? I would want to leave you with a little bit of an introspection here, right? And these are some of the questions we always ask ourselves, right? When in doubt, right? And you guys as a data leaders in your organization, right? It's important that you can gauge that, is your data easily available, right? Is your data well documented? Is your data standardized? Can third-party data be ingested, cleanly and easily, right? And obviously, it happens a lot, right? That your decisions are driven by data, not by that Hippo principle, right? The highest paid person's opinion, right? And again, this is some of the, I think, operating principles that we work with, right? And in your case, things could be a little different. You can evolve into that. But a classical data maturity cycle, I think it's important that, if nothing else out of this small section, kind of remember these things, right? As you sort of, move through your journey in becoming a more of a data-led organization. And all this we are doing is to go democratize our data, right? And by democratization, I does not only mean having access to the data, right? But having access and the processes in place to go derive the value out of your data. Okay, so as I sort of move to the next section in terms of the data transformation, and then I'll talk a little bit about transaction data enrichment, and this is where the value creation starts to happen. You're building your foundations for creating the value, right? So we work in a financial transaction domain, as I talked about it. We work quite a bit with what we call a financial transaction data. And if you look at, one of the classes of data, which is maybe say credit card transaction, I'll build out this slide. It's very interesting to note that, a simple transaction description that you see on your credit card statement is influenced by multiple players in the topology, in the topology of how a transaction happens. And very briefly, if I go through this, we have merchants where the transaction happens. It could be your Starbucks, it could be a website where you're trying to go buy, and there are more than 13 million of those in US. Gateways are nothing but APIs which are taking data from merchant and passing it on to the processors, and the acquirers are the ones who onboard the merchants onto their system. Acquirer processors actually interact with the gateways and through the card networks. Card networks, we are all familiar with the big four there, are the ones who provide the technical backbone, for this entire infrastructure, right? Issuing banks are the ones whose name is on your credit or the debit card, right? 9,000 plus of those in US, and the issuer processors, help do a lot of work, for the issuing bank. And only reason I'm showing you this slide is that you can look at the complexity of the topology of process of swapping a credit card and recording the transaction. There are so many of these players, and all these players can potentially work completely independent of each other, right? But they contribute somehow into how a financial transaction is recorded, right? And that's why it's such a hard problem if you're trying to go solve and infer entities out of it. It's a very hard problem to go solve, right? Because there's not a well-defined rule or the processes to go work through. So if I move forward in terms of the transaction data, this is a real example of a transaction description, right? And if you're trying to go figure out what's happening, maybe you'll figure something out, that something happened in Utah, maybe there's some restaurant, but this is an output which an end user would like to do, right? From that description, you would want to figure out, oh, that description actually happened at a merchant in El Heripo Grill. That happens to be in the category of dining. In fact, it was in particular a Mexican dining. Geolocation was in West Valley City, Utah. Here's the website. And this is the date transaction happened. In fact, the transaction happened not directly through, it happened through an intermediary. In this case, it was Square. And this is a physical store, right? So just see the difference between, the kind of things you as an end user or a financial institution can do if instead of having this as an input, you have this as an input, right? And this is very important that, and again, solving this problem is not easy. um, because you are trying to go in for multiple attributes from a description which looks like that, which does not follow any classical processes in place, right? And again, not getting into the detail of the data science per se. I think I did that a lot in the last year's presentation, but at a very high level, I think we are looking at an input that an example of an input I just talked about. There are multiple components, right, of data science that are running here, right? There are different modules that are running here, right? Not getting into the lower level of detail, but each one of them is potentially a big data science model that is running, right? So what we have done quite a bit over the last couple of years is a dramatically modularized, right? I think we used to be a monolithic sort of a system, right? And as we started to scale up, right, we have modularized a lot of our code, right, so that it keeps us very agile. We can make changes very fast. We can react to it. We can react to it very fast, right? And in this example, again, you take that as an input, you go through that, in the output, you can capture your merchant category, intermediary address, and a bunch of other things. And a lot of this is enabled not only by data science, but our engineering, right? As I said earlier, we use cache modules for efficient lookups. If we have run a particular pattern, earlier, there's no need to go run the model again. We should be able to just look it up and spit the output in much more efficiently. And all this is orchestrated through, hundreds of virtual machines and the containers that we're going through, right? So this is sort of a transformation I was talking about, right? That you start with a input of a transaction data, add value to it, and then that value creation happens, through using, very, very efficient engineering, right? And then outcome here has been that, now we process 100 million plus transaction. These go very, very, very efficiently. We're talking about, thousands of them, every second. We can derive up to 48 different attributes from a transaction description that I just showed you, right? And it's driven by, 14 different data science models that that are combined probabilistically, and this solution by itself has now five patents supporting it, right? So this was a little bit about how do we do that, right? How do we go deploy this, right? One thing I will say, right, a big operating principle that we are working off is you build once, deploy anywhere, right? Because in a company like ours, right, there are different classes of customers, different classes of users, right? So what we have done is sort of on the right side here, I talked about it, taken our data science, modularized that, packaged that, and working with that through an API layer. We use a global cache, as I talked about earlier, for efficiency, right? And then depending on the class of use case that we have, right, and how the delivery happens, right, on the consuming platform, in case of the batch delivery, we use Spark quite a bit. In case of streaming pipelines, we use Kafka streams, right, and in terms of real-time APIs, we use APIs, right? So the thing to keep in mind here again is the operating principle of build once, deploy anywhere, right? So we have been able to gain a lot of efficiency, right? By using this operating principle here. Now, I think switching gears a little bit on the business sense, right? So what I have talked about so far has been that we have been able to take raw transaction data, and now we can infer, right? This transaction, happened at, say, Walgreens. The category was general merchandise. Happens in Austin, Texas, and multiple other classes of enrichments that we are able to do now. And then that enrichment, we can use that enrichment and all that data to derive to the second level of attributes, right? From a given users, can you find out which transactions are recurring in nature, for example, right? Maybe you are making electricity payment, every month, or you have a gym membership, right? That can help understand the spending patterns. That can help understanding the earning patterns, whether you have a gig economy income, you have a regular income, and the investment patterns, right? So now you're going from the elemental level enrichments now, and then you're evolving more things from there. and that evolves into finding attributes, at a user level, right? And in our case, as I keep repeating that, we are in a financial domain, looking at all aspects of a user in their financial journey is something that I think is very important to us, right? So the evolution that we have done is from a transaction data, deriving it and taking it to the user level, right? So in a user's financial life, right, there are multiple aspects of it, and I'll walk you guys through each one of them, quickly, right? We have now an ability through our data sciences to get up to 3,000 different attributes about a user, right? And I'll talk about how do we go build those out, right? But if I look at the a user and the financial life, and if you look at an income, and if one of the attributes about the income part for this user is that the user is self-employed, there's an opportunity for the financial institutions to offer to set up a checking account or a direct deposit, right? And again, I'm just very going to quickly walk through that. In savings, if you see the user have propensity to do 529 planning or 401k planning, that gives an opportunity to offer customized savings and investment solutions. In terms of liabilities, if we see mortgage and auto loans, it's an opportunity to offer customized refinancing options. For insurance, for home insurance, for underinsured, you can offer life insurances. Similarly, understanding the investment patterns. If you're seeing equity trading on multiple platforms, you have an opportunity to connect to a financial advisor or a robo-advisor. Assets, right? If you see somebody with, with home, vehicle and boats, you can offer customized protection and insurance plans. Other financial habits, if you observe a users, with all expenses on debit cards, this could be an opportunity to offer something more customized. Or spends, right? If all spends are on restaurants or electronics, those could be specialty cards, with the benefits given there. And all I'm trying to motivate here with this slide is, in some sense of what you can do is limited by your imagination, right? What our science and engineering has been able to do is to take a very elemental data, evolve that to a customer, to a user level, and then a lot of these attributes that now we have derived thousands of attributes can help, enhance the financial life, and can help the financial institutions and the users both, in terms of providing value. So we go from attributes to the actionable insights. I think that's what I talked about earlier, right? How do you go from raw complex data to enrich that, to derive attributes, and from those attributes you derive actions, right? So this is where I think I'll try to talk a little bit around how the insights engine work, right? I've given some examples here, right? So far I think the classical, I think, CDPs, if you look at it, are a lot of times survey based, or based on what you have done on a particular website, or how do you navigate internet. A lot of times, they are either incomplete or have biases built into that, right? What we are trying to say here, and we claim that what you are doing with your money, how and where you are spending your money, is a much better reflection of what your propensity to buy is, what your credit worthiness is, and more importantly, it's very time sensitive, right? You're literally looking at this as of yesterday or day before, right? So this is real time, and it can get to a very microscopic view of a user, right? In terms of the actual patterns, right? But also as an institute, you can have a macroscopic perspective, right? That you can look at it, what's happening with your customer base, or with the big enough thing, you can look at what's happening in the US economy, right? So you get a much healthier view of of your customers, right? Of your end users, and helps provide, benefit both to the financial institution as well as the end consumers, right? So far, I think I've talked about, why, how is this better than the classical ways that you do your CDPs? I have talked about the multiple use cases around, how this class of, insights engine can help benefit into the a financial institution, right? But it's also important to kind of, see, how the sausage is made a little bit, right? So on this slide, if I look at it on the left side, the multidimensional segmentation, this is the what part of it, right? So what we are doing is, in somewhat, real time, figuring out the multi-dimensional segmentation for our end users, right? We are looking at our end users. We are figuring out what they are doing, right? And using multiple attributes, using preferences, using propensity to buy, right? How are and why are we doing it? Very clear, right? We are doing because we want to go provide personalized customer insights, right? And we want to deliver very individualized experiences based on exactly the need at that point of time for the users. And how are we doing that? I mean, I talked a little bit about that. We are doing that by using very advanced data sciences and data modeling. As I talked about it, we have thousands of attributes that we have derived for an end user, right? And this is a continuously improving process, right? This is not an end state in mind. As we learn more, these models learn from the data. There's a feedback loop that is already built in, and we continuously go improve these profiles, right? Now, if I sort of go to the next stage, right? And talk a little bit more about what kind of benefits this can potentially provide, right? So you can see that, in terms of and I think about, the insights engine as and if I look at, the financial institutions and I look at the end consumers, they are same side of the two different sides of the same coin, right? For the financial institutions, I'm taking a few examples. There could be hundreds and hundreds of, different use cases that we can talk about, right? But our focus is that, that you create all these attributes, and then you enable financial institutions to go, based on their objectives, deploy the right solutions for them, right? So one of them is the customer primacy, right? And I'll actually talk about this in a little bit more detail in the following slides, right? But more importantly is trying to understand what your customers are doing with you, right? And in a financial setting, I personally have lot of financial relationship. I have one of the banks I work with, where my salary comes in, my expenses happens. I work with the financial institutions where I have my investment, I have my 529 plans for my kids, my 401k for my retirement, right? But the banks are trying to evolve to a position where they have the primacy with their end user, that hence they can help the customer a lot more and can benefit themselves also, right? Also, depending on the life stage the user in, the classes of financial behaviors that they are doing, it's very important that this insights engine can help financial institutions with the right product marketing, right? Depending, again, you can evolve from a senior in a college with a working professional. That's a big shift in the life stage, in your spending habits, in your propensity to buy, right? And having an understanding of the life stages shift, helps the financial institutions offer the right thing at the right time. Also, in financial institutions, acquiring customers is hard, right? But what is worse is losing a customer, right? Now having having an ability and attributes that, that could be a leading indicator of an attrition. Financial institutions actually can use that to predict potential attrition, right, and proactively take action to go help avoid that. So again, the few examples here on the financial institution side, right. On the other side of it, if I look at, from an end user perspective, from a consumer perspective, some of the things like peer benchmarking, becomes very important, right? And a lot of us are very interested in what we are doing, as an individual, right? For example, me, in a certain role, living in, Raleigh, North Carolina, what are my peers doing? What are their spending habits? How much are they spending on dining versus me? So peer benchmarking is something I think we can all use, right? Budgeting sounds simple but hard, right? The users can evaluate spending habits and budgets towards the goal, planning for a goal. And some of the things I talked about in the earlier slides about, having an ability to figure out which the recurring transactions are, helps define, what the goal would be, right? And the spend simulation is the next part of it, right? Looking at the historical spend patterns can help users predict future spend scenarios, right? Again, the point I'm trying to make here is that, having the right insights engine built on top of the data can help both the financial institutions and the banks as well, right? So going forward a little bit, right, on the primacy use case, as I promised, I'll talk a little bit more around that, right? So we have sort of, built a framework, around generating different attributes around the user, right? So looking at, inter-FI transactions, even something like, using the ATM card to get money from an ATM from a particular financial institution is a reflection of, your affinity to that particular financial institution. Looking at the current usage and products, right? Looking at the technology usage and helps define where the customers are, right? You would want to understand what they need, right? As I talked about, evolving through the life stages, right? And working through those, right? It's important to understand, what their customer needs, what their classical or preferred mode of engagement is. Do they want to work with mobile apps, call centers? Do they want to physically walk into the store, right? And all this you're trying to do is to become their preferred banking partner, right? You help define the right customer satisfaction, you address the right pain points, and minimize churn, right? So this is one of the use cases that, how it helps, the financial institutions quite a bit, right? So if I go on the other side of it, right, and look for use cases, right? So this is again offering the right product to the right customer at the right time, right? So we once you understand the engagement level, right? Which card suits the user the best, right? So for example, right, if you want to target, customers, with high spends with their debit card, but low to nothing spend on their credit cards, right? Here's an opportunity to offer a new credit card, maybe with a very low interest rate, right? Or you opportunity to target users with high income and high spend. You can talk about premium credit cards. Similarly, right, target customers who have high propensity for a category specific spends, right? Dining, gas, right? You can have the reward kind of cards which offer cashbacks, right? And the last one is the target customers with high held away credit cards, right? So you can target the peer banks, credit cards. Again, as I talked about it, we're talking about, the both, and the two sides of the same coin. Having an ability to evolve this far is not only beneficial to the financial institution, it has a lot of benefits to the end customers, right? And creates a win-win situation, right? So now moving forward a little bit, this is basically a end-to-end simplified view of, how the delivery happens. I talked about that, the middle part is where all the modeling and everything happens. You work with the data sources. There are multiple ways to deploy this. I'll show you some examples here, right? But we aggregate data, we do a lot of data science to go enrich that, then we take the output of that enrichment, we build further models of that at a user level, and then those outputs in a different way packaged and consumed through either dashboards or in sophisticated users through querying tools, right? And several applications have been built, right? So here is an example of a dashboard, right? And this is again for an end customer, which are not very sophisticated, technically. They can use this dashboard, where multiple pieces of information and insights are there, right? And they can help drive their decision making there, right? So we have pre-built dashboards. They have created insights.
We are about 10 minutes.
Thanks.
From the end.
Thank you. We evaluate customer trends and then we extract data sets, right? Again, a lot of our end customers are very sophisticated, right? They want access to the raw data, not only a customized dashboard, right? So we have an ability to go provide that, and we use Snowflake to go do that. Here is a bit of a deployment topology, right? So of how this happens, right? As I talked about, the data coming in, this is the middle section where all the magic happens in terms of data refinery and the data enrichment. And the last part is the consuming platform, right? So depending on the users in the different parts of the country, right? We have a deployment topology, right? For different classes of users. So think of that, as, again, the central part is your data, is your refinery and the enrichment engines and the data science part of it. Last part is our consuming platform, which are highly optimized based on what user wants and where they're located, right? And all this is coming through a data source that we are getting. Right. So now to sort of, close out a little bit, in terms of, I'll just briefly touch on that in the interest of time, that, a lot of times I think we see got very popular in the internet world, the A/B testing model, right? You have a set of users, you do A/B testing, you show some option, you try to find some version of lift, you give your other option, you find a lift, and then you find the winner. In our domain, we're trying to do something little differently and still work in progress in some sense, right? I mean, we are trying to go quantify that can we have an ability to go quantify each recommendation that we are making for a user, right? These recommendations are coming through ML models, right? So we are looking at the cost of providing the service to the business. We are looking at the projected business value of the recommendation and the probability of user acting on it, right? And trying to sort of use all of this, again, work in progress. We are not done here, right? Try to figure out what's the current value to be gained from a particular recommendation for a particular user, right? So trying to again work with the so-called segment of one here, right? And this is something that we are trying right now. Okay, so in the interest of time, I think I'll try to wrap up, right? And I mean, if nothing else you got out of the presentation, what I would like to do is that, you got to know what your core value proposition from the data is. That is very important, right? And a lot of things that I talked about, in this presentation will fall in place, right? For us as a financial company, right, our focus was that, creating an intelligent and connected financial life for a user, right? That was our core value proposition, and we sort of, work backwards from there. And it does, as you can see, it does involve some very sophisticated, science, and engineering and the processes in place, right? And as I said, if nothing else, kind of keep these kind of three things in mind, that, when you're looking at your user, figure out a way of, quantifying them, across big dimensions, right? In our case, we were able to get into thousands of them, generate actionable insights, where the customer and the financial institution can act on, right? And ideally personalize the recommendation, at the user level, right? So that's the journey from the data to the insights to the opportunities or the recommendations, right? And I must say that, while doing that, while I take a lot of pride into doing our data science, and a very strong team we have, end of the day, this is man-machine synergy, right? And there are multiple examples I can talk about that, this is neither science, not only the human. I think it's a synergy which in totality creates value and creates solutions that can help, both the institutions and the end users, right? So with that, I think I will stop, and maybe open it up for any questions.
I have a question. It seems like now everybody's talking about artificial intelligence. What skills does your team have, or what skills do you think need to be? How many teams, or what types of skills are you looking for, or you needed in order to get all these solutions going?
Very, very good question, Ali, right? Again, as you can see, and I'm a big proponent of that, to take real solutions, right? And deploy, to build solutions and deploy them. I always talked about, broadly speaking, it's a three-legged stool, right? That you need strong data science. That means people with strong, math and computer science background, who can actually go build models. You need strong business analytics, meaning people who understand business, can work with your sales and the product teams, understand the business problem, figure out, how that can be solved, right? But also the third part of the stool is a strong analytics engineering, right? Which is a little different than, what classically you do the engineering, right? Because a lot of things that you are doing are probabilistic in nature, right? So you need people that who can understand that part of it, right? So in some sense of, having these three core legs about having business analyst, your big data engineers, as well as your data scientist. But that by itself is not complete. As we got into the details of it, you need teams, which can, like as you go into production, the models can drift. The thing that the core data can change. Even a model getting into a production, how do you know it's better than the model which was already out there, right? So we ended up creating what we call the validation engineers, right? These are people who can think like a data scientist, can even create challenger models, right? And test that, right? As I talked earlier, you also need human experts who can help create ground truths or label your data, right? So again, the data scientist is probably 20% of the equation. You need the full ecosystem and infrastructure to go deploy that, right? It's very important that this will not happen in isolation. And even if one of the three legs are weak, you will not have a fully sustaining organization with a lot of data science enabled solutions behind it.
Okay, thank you so much. It was a very interesting and kind of, it was interesting to see how you put everything together. I like the history, because everybody kind of will have to go through more or less some of these, hopefully maybe faster now, kind of having all this knowledge behind us. But that's about it for our session today. And I want to thank Dr. Pramod Singh for his talk, and thank you all for attending.
Thank you so much. I really enjoyed it, and thank you all for attending it. Thank you.